This video is going to be about electric potential. And at first we're going to look at an example about gravitational potential. This video is going to be about electric potential, and first we're going to look at an example using gravitational potential. Gravitational potential is gravitational potential energy divided by mass. And if you think about gravitational potential energy, that is calculated using gravity times mass times height. Whereas gravitational potential is potential energy divided by mass, which is this gravity mass times height divided by mass. So basically I'm losing mass, and gravitational potential is merely gravity times height. And so what gravitational potential is, it is basically how much potential energy you have per unit mass, and it is merely location dependent, right? So it's really about how high you are from the ground, for example. Okay, so here we have a set of rocks. This first rock here is 1 kilogram and 2 meters from the ground. It has about 20 joules of potential energy. If you consider gravity to be 10, we would have gravity is 10 times the mass of 1 kilogram times the height as 2 meters gets us 20 joules of potential energy. So if it's gravitational potential is potential energy divided by mass, that's now 20 joules divided by a mass of 1 kilogram. We end up getting 20 joules per kilogram for gravitational potential. Similarly, we have a rock at the same height but of a different mass. And so here we know it has 40 joules of potential energy because its potential energy is gravity times its mass times its height, which gets us 40 joules of potential energy. But its gravitational potential is its potential energy divided by its mass, which gets us again 20 joules per kilogram. So regardless of mass of these two rocks, because they're at the same location, they have exactly the same gravitational potential, and you'll find if you do the math that these two rocks at a height of 1 meter have also the exact same gravitational potential as each other. Similarly, we can talk about electric potential. And electric potential is again potential energy, but here instead of being divided by mass, it is being divided by unit of charge, which is Q. And again, it's merely talking about how much potential a specific charge has based merely on its location from something creating an electric field. And we know that this object here, by convention, is creating an electric field that points away from that object. So if it is PE divided by Q, this small charged object with 1 unit of Q is 10 potential energy in joules divided by 1 coulomb, because Q is measured in coulombs, getting an electric potential of 10 joules per coulomb. This larger object here has 20 units of potential energy, and if I put in appropriate units for that, that's 20 joules of potential energy divided by 2 coulombs gets us again 10 joules per coulomb. So even though it has larger potential energy and larger individual charges, merely because of their location respective to the item creating the electric field, they have the exact same electrical potential. And so we can talk about electric potential in a circuit, and we will usually think of following a positive charge through a circuit. Therefore, the positive terminal of a battery has the highest electrical potential, merely based on its proximity to the positive, when we know positive points away, and we always talk about what a positive test charge would experience. And then the negative terminal would therefore have the lowest electrical potential. This will actually be the same with potential energy as well. Positive terminal will have high potential energy. Negative terminal will have low potential energy. High and low.